Hello everyone. Today let's solve the problem number 213. Previously we had solved house robber 1, right? So today we'll be solving house robber 2. So what the question states here, we are given an array nums. You can clearly see here we are given an array nums where each element represents the money in the houses arranged in a circle. So just keep this in mind, arranged in a circle. So where each element represents money in the houses arranged in a circle. This is money stashed in the particular house, right? 2 and the first house 0th index, 3 and the second house first index, 2 again and the second index third house, right? So each element represents money in houses arranged in a circle. You cannot rob two adjacent houses. They have strictly mentioned you cannot rob two adjacent houses. We cannot rob the two adjacent houses. They have security systems, right? So our goal is to rob the maximum amount of money without alerting the police. So that's what they have given here. What is our main goal? To rob the maximum amount of money without alerting the police. So just keep this in mind here. Just give me a second here. So here in this case we have 2, 3 as well as 2, right? So this is basically in the circle, right? So this is basically in the circle. So that's what I wanted to say. This is basically in the circle, right? So what happens here, the first and the last house we cannot rob here. First and the last house we cannot rob because these are adjacent houses, right? So they have clearly said in the question that each element represents money in the houses that is arranged in a circle. So always keep in mind the first, we cannot rob the first and last houses as they are adjacent houses, right? So either we can go with this one, first and last house we cannot rob, right? So we have to just go with this one, the middle one. So this one we will ignore. First one, you can ignore first one or the last one, right? So if you ignore the first one, when you ignore the first one we have to consider max of 3 comma 2, right? Or when we ignore the last one we have to consider max of 2 comma 3. Both give us 3 itself in this case, right? So in this case the output will be quite obviously 3. So we cannot rob house 1 money equals to 2. Explanation I am reading here. We cannot rob house 1 money equals to 2 and then rob this one house 3 money equals to 2 because they are adjacent houses. This one they are speaking of, first one and the last house as I've shown, right? Let's come to the second example here. Nums equals 1 2 3 1 they have given here. So in this case 1 and 1, this one we cannot rob, right? So rob first house. Let's go with this one and this one as we need the maximum amount that can be robbed, right? The first one and third one. So in this case rob house, that is nothing but money 1 here in this case, and then rob house 3. So this one will give us 1 plus 3 equals 4. So this will be the maximum. So we have to return 4 as output in this case. In this case let's come to this one, third example. We have 1 comma 2. So here what we'll do, we'll ignore this one, the last one, the first one and the this one will consider, right? So this will be basically 3. Sorry, we'll leave this one, first one and second one. We'll go with the third one, right? So we'll consider max of 2 comma 3 basically. First and last we cannot consider. So this will be 3 itself, right? In this case. So I hope the question is completely clear. What we need to do is completely clear as well, right? Easy to understand. The only difference between the house robber 1 and house robber 2 is so here in this case the houses are arranged in the circle, right? So the houses are arranged in the circle. We cannot consider first and the last house. That is the main difference. That is the only difference, and that is the main difference basically, right? So we cannot drop first and last houses. So just keep this in mind, right? Now let's discuss the approach first, followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, let's discuss the approach. So the first thing that we need to keep in mind here is we will be going with the dynamic programming, right? So just keep this in mind. We'll be going with the dynamic programming. So I've considered the same first example that they have given in the question, right? So that it will be easier to understand. So we have already discussed this one, right? So this will be 2 3 2. Output we need to get here as 3. Why? Because we have this one in the circular, right? So we have this one in the circular house. So let's draw this one like this, right? So sorry. So just give me a second here. So this one here in this case we cannot consider this one and this one. Why? Because this will be the adjacent houses, first and the last house, right? So there are two steps here. Just go, let's discuss this one step by step. In the circular array, robbing the first and last houses is not allowed. That's what I said, right? Robbing the first and last houses is not allowed. So let's split this one into two linear cases, right? So let's split this one into two linear cases. Nothing but rob from house 0. Rob from house 0 means this one. This is house 0, this is house 1, and this is house 2. So rob from house 0 to n minus 2. N minus 2. This is nothing but this one. This one and this one we are speaking of, right? Rob this one 0 to n. Rob from 0 to n minus 2 is this one 2 and 3 we need to consider here in this case, right? So this will be 2 comma 3. And drop from house 1 means 1 to n minus 1. Here in this case we will not consider 2, we will be considering these two, 3 and 2. This one either consider 2 3 or 3 comma 2. Here in this case 3 comma 2, right? So we can go with either of the things. So we will take the max of two results here in this case. Case 1, we will drop the house, nothing but. So what we'll do here, for the case 1 we will drop the house here 0. For the this one, rob house 0, nothing but 2. When we rob house, nothing but 3. Here I am speaking of 2 comma 3. We have already considered this one, right? Here this one 2 comma 3. Out of 2 comma 3, which one is the max? Max of 2 comma 3 is 3 here in this case. So we are considering max here. Max of 3 comma 3 is max, right? So 3 is 3. So in this case, when we rob the house 1 and house 2, we cannot go with first and last house, right? Either we went with house 0 and house 1 for this one. So for this one we will be going with a house 1 and house 2. So house 1 is having the value 3 and 2. So max of 1 comma 2 gives us max of this one, not 1 comma 2. House 1 value is 3, house 2 value is 2. Max of 3 comma 2 will give us the output 3 itself. Max of 3 comma 2 is 3 itself, right here. In this case also we got 3. So final step is we got 3 here and we got 3. So we have to go with the max, right? So the maximum amount that can be robbed, right, within the houses in the circle that we need to consider. Here finally if we go with max of 3 comma 3, in this case we'll get the max itself. In this case we have 3 for both, right? In other cases we might have 6 comma 4, something like that, right? We get the maximum this one amount that can be robbed, right? Basically that is the reason we'll consider max of this step as well as this step, right? So in this case max of 3 comma 3 gives us 3, right? So 3 is the solution that we got, which is equivalent to the output that they have given for the example 1 in the question. So these two basically matches, right? So the output that we got is equivalent to the first output they have given for the example 1 in the question. So now this is the approach that we'll be going with. Now we are completely familiar with the approach. As we are completely familiar with the approach, let's discuss the approach step by step, right? So just give me a second here. Let's discuss the let's discuss the edge cases one by one. Sorry, I got confused here. So the first edge case is for the when nums equals 5, means when we have only one element, means one house. Sorry, just give me a second here. Yeah, when we have only one house. So when we have only one house, we will rob that house directly. So output will be quite obviously 5. So let's come to the second one here, right? So we cannot rob both in this case because these will be adjacent, right? The first and the last house here, 4 3, right? So we will be choosing the max. So first we'll go with the first two linear cases. It will be, so first case we'll be considering only 4, and the second case we'll be considering only 3. Max of 4 comma 3 will be quite obviously 4 in this case. Output is 4. So let's go with the third edge case here. Nums equals 0 comma 0 comma 0. So all houses have 0 money stashed in it here in this case, right? So here the output will be quite obviously 0. We can directly consider 0 here on this case, right? So let's go with the fourth edge case here. We cannot rob both first and last due to the adjacency here, right? So we can either again we'll go with the two linear cases, right? So same way we went with this one, similar way, right? So the output will be quite obviously 1000. So the output will be quite obviously 1000. So if you want the step by step, if you want to understand this one step by step, you can just go in the same way. You can just do in the same way that I showed for example 1 in the approach. For the fourth edge case, I'm speaking of how we got 1000, right? So I insist you to try in the same way, right? So you can just try it out so that you understand the problem correctly, right? So these are the four edge cases that we need to keep in mind. Now we are completely familiar with the edge cases as well as the approach. As we are completely familiar with the edge cases as well as the approach, let's start writing the code. First step here, let's get the total number of houses first. So here I'll just go, we'll be making use of length of the nums within the code, right? So I'll just assign this one to the n so that we don't have to write nums.length again and again, right? We can just make use of the variable n here. So this is fine. If there is only one house, then we have to return its money. We have discussed this one in the edge case, the first edge case, right? If there is only one house, then we have to return its money. Base case, simple. If n equals 1, then what we will do? We will return nums of 0 and the first house, right? The value that is present in the first house will return the same thing, right? So since the houses are arranged in circular, we know that, right? So they have clearly mentioned in the question, houses are arranged in circle. Since houses are arranged in circular, we have to take max of the two cases. Two linear cases we considered, if you remember, same thing. Rob houses from the index 0 to n minus 2, or rob houses from as well as rob houses from index 1 to n minus 1. For the first one, when we are robbing the houses from index 0 to n minus 2, we will exclude the last house. For the second one, when we are robbing the houses from index 1 to n minus 1, we will include the first house. I mean exclude the first house. Sorry. Yeah, so in this case, I'll just return math.max of rob linear, this one nums, 0, n minus 2. This is fine. So here again, rob linear of nums, 1, n minus 1. This one I did a mistake here. So this one I should have written this one after writing the, what do you call, helper function. Basically we'll be going with the rob linear helper function, right? So I should have written this one after this one. This is fine. Anyways, let's write the helper function here. So private, and so I'll just give the function name here, rob linear. So the parameters that I'll consider here as nums start as well as the end. So I'll just go with nums start as well as end. So this is fine. So the first step here is the base case. If we have only one house in this range, then we have to return its value, right? So we have written in the same thing in the main function as well. So here we have the parameters start equals start and end. So if start equals end, then what we will do? We will return nums of start, means we will return the value that is present in the first house. So this is fine. Let's move on with the next step. We'll be making use of the DP array, right? We have to store the maximum, this one, money that we have robbed, or max loot, right? We can just call this one max loot. We'll be making use of the DP array to store the max loot till each index. So I'll just go with here int DP new int of, so this one will be end minus start plus 1. So this is fine. I hope this is clear. Let's move on with the next one. So here, if you know the base case, the first house, when the first house is robbed, so how can we articulate that one in the form of code? DP of 0, I'll just give here this one to nums of start. So this is fine. Next step is we will choose the max of first or second house. So here in this case, I'll give dp of 1. This will be math.max nums of start. This one nums of start plus 1. So this is fine. Let's move on with the next step. So for each house, we have to decide whether to rob this or skip this, right? So for each house, we have to decide whether to rob this or skip this. Means we have to add dp of I minus 2 or we have to skip dp of I minus 1. That's what we need to decide, right? So I'll just go with dp of I for this iterated value of the dp here as this one. Let me go with the math.max of dp of I minus 1 comma dp of I minus 2 plus nums of start plus I. This is fine. The final step here is we have to return the last value as the result for this linear case. Means I can write in this way: return dp length minus 1. So this is fine. So now we have successfully written this one helper function as well. So after writing the helper function, I should have made use of this one here, right? So first itself I have written. I should have written after this. This is fine. So let me format this one once and let me hit the run button. I hope this works. Let's see now. So we have the error here. dp of dp dot length minus 1. What we have here? Error illegal start of the type. So what did I do here? Just give me a second here. Didn't I give this one? So we should have went with a for loop, right? I didn't go with a for loop, yeah? Just give me a second here. I have made mistake somewhere. So yeah, before iterated value of the dp, here I should have went with a for loop. So for each house, we have to decide whether we have to rob this one or skip this. Before that one, we have to iterate, right? So I forgot this one. Let me write this one quickly. And we are going with the third house. Sorry, I equals to second one. I less than length of the dp. Let me increment the dp here. This is fine. So this one, let me write this one here. So this one, let me cut this one here. So let me paste this one after this. Let me format the code once. Let me hit the run button. Now this has to work. Let's see. Yeah, now we can clearly see the sample test cases are getting passed. Once the code works absolutely correct in this case. So let's quickly hit the, let me quickly hit the submit button. So let's see whether this works for all the test cases or not. So yeah, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case. Let's quickly discuss the complexities for the code that we have written. So here the approach that we went with here is dynamic programming with circular constraint, right? We know this. So we went with the dynamic programming with circular constraint, or we can just call this one as dynamic programming, right? So what would be the overall time complexity here? Overall time complexity would be big of n. How it is big of n? Basically, we are going with the 2 passes over the array. Means n minus 1 length each, right? So we are going with the 2 passes over the array. So quite obviously this one. Quite obviously here this one, what do we call? The time complexity here is big of n. So what would be the space complexity? The space complexity would be big of n as well. Why it is big of n? Because we are making use of the dp array, right? To store the results. So here, where is dp array? Where did I make use of the dp array? Here you can clearly see line number 15 I am speaking of. So we are making use of the dp array to store the results for each linear case. So overall space complexity would be, in the worst case, it would be big of n. So the time complexity and the space complexity for the code that we have written is big of. I hope the complexities are clear, and I hope whatever the code that we have written is completely clear as well. Right? For now, this is it. Thanks for watching, guys.